Hello, my name is Sean, and I'll be covering Yellow Cipher. So, to start off with, I'm just going to write all the information here. So this is going to be Delta Bravo Romeo Oscar Foxtrot Oscar. Then we got our numbers, which is 4865 and 72. And we have our keyword being notebook. And finally our four numbers again, 25, 2, 9, and 11. So, to start off with, the first step is going to be Morbid Cipher. To do Morbid Cipher, we're going to need the numbers that we got on the, middle screen page 1, bottom screen page 1, as well as top screen page 1. And we're going to concatenate all of them. So 48 goes first, then the 65, then the 72. Next, we're going to take our keyword here, and we're going to label some numbers underneath so that it goes in alphabetical order. So the one in this instance will go under E first, because that's the first in alphabetical order in this module. And then I see a K there, that will get a 2. And then let's see, A, B, C, D, E, F, G, H, I, J, K, L, M, N. There's an N there, and then O. Now there are multiple O's in this keyword. So what I'm going to do is I'm going to give the first O in reading order, the next source number, then the next O, and then the next O. So basically this O gets the 4, then this O gets the 5, then this O gets the 6. In fact, I did this all wrong, because the B goes first, doesn't it? So this gets 1, 2, K gets 3, 4, 5, 6, 7, and then the T gets 8. So now all these numbers are placed under alphabetical order as they are in the keyword. I'm going to get rid of the keyword here, and I'm going to place under this 8-number key this string here, and that is our key. Then for each of these numbers, that is our encrypted word, we're going to place some dots and dashes according to our key. So the 4 translates to dot dot, 8 gives us dot x, 6 gives us dash x, then the 5 gives us dot dash, then 7 gives us x dot, and finally 2 gives us dash dot. And all these dots, dashes, and x represents is some Morse code. The x's represents the breaks within the Morse code that you usually get from, the vanilla module Morse. So the x's are just basically treated as if spaces. And then we're going to translate all the Morse code between the breaks into letters. So dot 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 refers to S, dash refers to T, remember, and then dot dash is an A, and then finally dot dash dot is an R. So we get in our decrypted keyword of star. And this keyword can be a length of 4 letters all the way up to 8 letters long. So keep that in mind. Next is going to be trifight cipher. Using our keyword that we got from step 1, we're going to remove any duplicates in it. So there isn't any duplicates, but if we had notebook, for example, we have N-O-T-E-B, and then these 2 O's would go away, and then the K. So remove any duplicates. So for star, there are no duplicates. Then we're going to get our alphabet here. C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And we're going to remove all the letters that are shown in the keyword that we have. So S, T, A, and R. Then, if the number of batteries is odd, which it isn't odd, there are 2 batteries. Otherwise, place the alphabet at the beginning of the keyword, so that way that the alphabet is in front. So it's the alphabet first, then our keyword. Then we're going to place these row of numbers underneath our key here, and that is our completed key. Now for each of the letters here of of our encrypted word, we're going to translate each letter into a number. So this D here, you look up D and you basically read off the numbers top to bottom. So this would translate to 113. So 113 becomes our first one. B is 111. Then R, finding R, is 332. O is going to be 222. F, if we find F, is 122. And then O again is going to be 222. Then we're going to split these numbers into rows so that each row contains 6 numbers. To do so, I take the first 2 numbers, and that'll be our first row. Then the third and fourth numbers become our second row, and then finally the fifth and sixth numbers becomes our third row. Then we're going to read these numbers top to bottom, left to right. So our first one is 131. So we gotta find 1 here, and then find our 3, and then 1 is going to translate to hotel. And then find 1, 3, 2 turns into India. Then 3, yeah, this is 3, and then 2, 2, so 3, 2, 2 is an S. Then 1, 2, 2 is an F. And then okay, they're all 1, 2, 2s. So this would be F and F again. Interesting enough. So HISFFF. And that is our new encrypted word. And we don't need this anymore. On to the third step, which is Yellow Cipher. Now, Yellow Cipher is going to use our new encrypted word that we got from step 2, as well as our 4 numbers that we got from the bottom screen of page 2. And the first thing to do is we need to find the inverse number of n of this equation, which looks something like this. And the numbers here are labeled A, B, C, D as accordingly. So we have A times D, so that's going to be 25 times 11. So if I plug this into our number calculator, 25 times 11 gives us 275, minus our B times C. B times C is 2 times 9. That's going to be 18. So 275 minus 18 is going to give us 257. 257. And this is going to module by 26, which is 23. Oh, excuse me here. 23. So, with that, now we have to set this equation equal to true. So, n times 23 modules 26 has to be 1. And what most people usually do is they brute force this step. So, n has to be a number between 1 and 25. And n has to be, as well as n has to be a odd number as well. That's the 2 things n has to be. It has to be a number between 1 and 25, and n has to be an odd number. So that usually gives off 13 different numbers that could be. So because of that, most people brute force this. So we do first n1 being 1 times 23 being 23, and then we module 26 makes it 23. So that's not it. So then we do 2, not 2, delete this, delete all of it. How I clear this? There we go. So that'll be 3 times 23 modulo 26 gives us 17. That's not it. So we do 5 times 23 modulo R26 gives us 11. Not it. So that was 5. So we do 7 times 23 modulo R26 gives us 5. 9 times 23 modulo 26, 25, that's 9. So 11 times 23 modulo 26 gives us 19. 13 times 23 modulo 26, 13. 15 times 23 modulo 26. 17 times 23 modulo 26 is 1. So I'm going to do 391 divided by 23. So it was 17 that I put in. So that means n is equal to 17 because it makes this equation all true. Now that we figure out n is equal to 17, all we got to do now is set up our matrix so that we arrange the 4 numbers like so. So D is going to be in the top left, so 11 goes in the top left. Then we have a negative B, so it'll be negative 2 in the top right. Then a negative C, so negative 9 goes in the bottom left. And finally, A, which is 25, goes in the bottom right. Then we're going to multiply all these numbers by 17. So we have 11 times 17 equals that, and we're going to module them by 26. So this new top number becomes 5. Okay? So 2 minus 4, I'll make it negative 2, times 17 gives us negative 4. Modulo, or 26, gives us 18. Then we have 0 minus 9. And then we have times by 17. Modulo by 26 gives us 3. And finally, 25 times 17 gives us 425. Modulo 26 gives us 9. Now we have our inverted matrix. Now, for our encrypted word here, we're going to split the encrypted word into letter pairs. And for each letter pair, I'm going to turn the first letter into its alphanumeric position, and I'll represent our top number. And basically, then our second encrypted letter, turn that into its alphanumeric position, so A, B, C, D, E, F, G, H, I, which is 9, and that'll be our bottom number. Then what we do, and I'll place some braces here, we're going to multiply our top left number by the top number, so 5 times 8, and then we're going to sum this up by the top right number, which is 18, multiplied by our bottom number, which is 9, in this case right here, and that will give us a number of 202. And then we're going to module this by 26, and that gives us 20. And when we do this, we're going to take the 20 and turn it back into its equivalent letter, treating the 20 as its alphanumeric position. So the 20th position in the alphabet would be T, and that would be our first decrypted letter. And then we're going to do the same for our second one, but just a little bit differently. So we're going to take our bottom left number, which is 3, times our top number, 8, sum it up by the product of our bottom right number, so our 9, times our bottom number, which is 9. We get 105, modulo our 26, gives us 1. And the first letter in the alphabet is an A. Alright, and then we do the same for each letter pair. So S is going to be 19, F is going to be 6. So now it's going to be 5 times 19 plus 18 times 6. 203 modulo 26 gives us 21, which is AU. Then we'll do 3 times 19 plus 9 times 6. Gives us 111. Modulo 26 gives us 7. EF, that's a G. I know what this is. At least I hope so. And then on to our next one. So this is F and F. So this is going to be 6 and 6. So it's going to be 5 times 6 plus 18 times 6. 138 modules 26 gives us 8, which is an H. Then 3 times 6 plus 9 times 6 gives us 72 modulo 26 gives us 20. That's a T. And that will give us our decrypted word of taught. Now, to just like every card cipher, what we're going to do is, if you press on the keyboard, it will start into submission mode, and you start inputting the word like so. And if you ever want to clear out your submission, you can press any of these arrow keys there to just clear it up. So T-A-U-G-H-T. And to submit, you press the submit button. And that is solved module. I hope all of you enjoyed this tutorial. And until next time, guys, keep talking and don't explode.